You wake up, feel the morning heat through the window, stretch limbs that are slightly longer than last month, and flick on a light switch. The human brain usually categorizes these moments as disconnected events. We perceive our morning as a series of localized, random phenomena occurring one after the other. Mapping the hidden links between those moments is the core of jingyasha, or curiosity. It is the drive to understand why our world develops the way it does. Standard education often groups biology, chemistry, and physics into separate chapters. This approach suggests they are isolated subjects to be memorized for a grade. In reality, these disciplines function as interlocking gears. Our daily lives are the direct result of a continuous chain reaction, where one scientific principle powers the next. The first gear in that chain sits 93 million miles away. Everything happening on Earth begins with the gravitational relationship and spatial positioning of the Earth, Moon, and Sun. This model shows the Sun projecting energy, blasting light radiation to strike the Earth's surface. Hitting objects creates immediate physical results, reflections, and distinct shadow zones. Simultaneously, unreflected radiation is absorbed, transferring heat through the natural environment. The movement of distant celestial bodies provides the literal, active power source for the physical changes occurring on our planet. Once that solar energy reaches the surface, plants act as biological receivers. They absorb heat and light to fuel their fundamental life processes. Animals then consume those plants, transferring that stored solar energy up the food chain to sustain their own biological functions. When you eat, you are consuming that transferred energy. Your body breaks it down into raw fuel for physical development. During adolescence, the body directs massive amounts of this fuel toward specific growth spurts and cellular changes. The physical maturation of a teenager is the biological result of a physics process that began with the sun. To interact with the environment, we look outside the body. Every object around us undergoes constant physical and chemical changes. We categorize matter to understand these changes. We identify chemical properties, like acidic, basic, or neutral. We then divide physical elements into metals and nonmetals, measuring convectivity. Identifying these properties allows us to build circuits and harness electricity to power technology. To track and quantify these transitions, we rely on the tools of time and motion. Chemistry and physics provide the instructions humans use to measure and direct the universe's energy. A solar reaction fuels a plant, which feeds a human, who then uses that energy to manipulate metal and electricity. A science syllabus organizes these seemingly disparate topics into a single system. It connects the macro scale of the stars to the micro scale of our own biology. Keeping this system clear requires constant curiosity, the drive to observe how the pieces of our environment fit together. Understanding these connections shows that we are active participants in a larger chemical and physical process.